Alright, so day 2 notes of law of cosines. So the last time I talked about law of sines, we had that formula. Now with law of cosines, we have 3 different formulas depending on what was given. If you're given angle A, then you're going to use this equation. Given angle B, this one, and angle C, that one. I'm going to show you for the second problem how we could solve those for cosine so that if we're looking for an angle measure, we are able to have one formula to do so. And I'll give that to you all on the quiz or test if you would like to use that. So let's look at why we have to use the law of cosines for side angle side problems. So again, be visual, show and draw your triangles. And so with this problem, we're given that angle A is 115 degrees, side length B is 15, and then C is 10. So you can see from this problem that you don't have enough information to use law of sines because we are given angle A but not length of A. We're given B, side lengths B and C, but we're not given those angles. So we have to use law of cosines. You are going to be given problems where we're not going to tell you SAS or angle side or anything like that. You're going to have to know which law to use for which problems. So we're again solving the triangle. So that means we're going to have to find every piece of information that is missing. So we're going to find side length A, we're going to find the measure of angle B, and then we're going to find the measure of angle C. So since we're given angle A, we're going to use this equation for law of sines. So A squared equals B squared plus C squared minus 2BC times cosine of A. So A squared equals B squared, so 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 115. Now at this point you could honestly put that all in the calculator and it can give you what A squared is. But if you make one little mistake in the calculator, you're going to have to retype the whole thing. So let's try to do some work on its own. So what I'm going to do is do a little bit of arithmetic. So 15 squared plus 10 squared is 325. 2 times 15 times 10 is 300. Cosine of 115. Now, the biggest problem I have with students in this type of problem is that they want to subtract 325 minus 300, and you cannot do that. It does not become 25 cosine of 115. It stays exactly like that. So we put that into the calculator, cosine of 115. Now, make sure that you are in degree mode, because if you are not, you will not get the correct answer. So A squared equals 451.785478.5, and I do that so that you don't use the rounded values. So square root both sides. So we're going to square root that in the calculator and get that A is 21.255. So now that I have figured out the side length of A, I need to figure out what the angles B and C are. And you could use law of cosines again to do that. Or since we now have both an angle A and a side length A, I can use law of sines. So I'm going to do sine of 115 over that number. And again, make sure in the calculator you don't use the rounded values. And honestly, it doesn't matter what you choose to do next. I'm just going to do sine of B. So sine of B is going to be 15 times sine of 115 over that rounded value. So anytime you need to find an angle measure, you have to do the inverse. So I'm going to do sine inverse. Fancy fraction. 15 sine of 115 over that rounded value. And I'm going to actually have to type in all of that on my own, because you can't copy it and paste it in the denominator. So we get 39.761 degrees. Now, some of you might be like, oh, last class we had to do the supplement as well. Well, we can't do the supplement of this and be part of this triangle. Each triangle can only have one obtuse angle, obtuse being bigger than 90. If you had two angles bigger than 90, you'd add up already more than 180 degrees. So that's your only answer. So now that we have two angles, all I have to do to find the measure of angle C is subtract A and B from 180. So 180 minus 115 minus that angle gives us 25.239 degrees. And again, check to make sure that your triangle makes sense. A is the biggest angle, so A is the biggest side length. C is the smaller side length, so it should be the smaller angle. Makes sense. So now, what I'm going to do is, if you look at the next problem, we're given side, side, side. So we don't have any angle measures. So what we're going to do is we're going to need to solve this equation for B. So the one that's B squared equals A squared plus C squared minus 2AC times cosine B to be cosine B. So I'm going to do this on a separate sheet of paper. You can copy this down if you want to. So what I'm going to do is I'm going to subtract the A squared and C squared on both sides. And that's still negative 2AC. And then divide both sides by negative 2AC. So when I do that, I'm going to get left with cosine B on one side, but I don't like that negative there, so I'm going to multiply everything by negative 1. So that makes this negative A squared positive, this negative C squared positive, and this positive B squared negative. So that's how I'm going to get that equation. And again, I'll give you one form of that for the test if you would like to use it. It makes it a little bit easier, a lot less mistakes if you use this formula. So I need to figure out cosine B, and maybe some of y'all are asking, why did I choose the B one? Well, if you read what's in the circle, it says it is always better to find the largest angle first. Law of cosines is very particular about which angle you find first. You have to find the biggest angle first. Remember that the biggest angle has the biggest side length. So since B is the biggest side length, we're going to have to find the biggest angle, which is going to be B. So let's plug in what we have. So cosine B is 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14. So I'm going to do a little bit of arithmetic in my calculator just so that I can not do a lot on my own. So 8 squared plus 14 squared minus 19 squared is negative 101. Two times 8 times 14, 224. So here I need to find an angle measure. Anytime you're using or finding an angle measure, you have to use cosine inverse. And I'm going to leave that as a fraction. So when I do that in the calculator, cosine inverse, you can use a fancy fraction if you want to. 101 over 224, and we get 116.801 degrees. So we could make a list of what I need to solve for. So we just found B. And then we need to find C. So now again, it doesn't matter what order you do this as long as you have the largest angle first. So let's just do it alphabetical and find A. So sine of A over 8 will equal sine of B, which we just found out is this, over 19. So sine of A equals 8 times the sine of 116.801 over 19. So again, looking for an angle measure, but we're using law of sines, so we're going to do sine inverse of this. So let's put that in the calculator. Sine inverse, nice fraction, 8 sine of, go and grab that answer, over 19. And we get 22.075 degrees. And again, to find the third angle, just subtract the other two from 180. So 180 minus this, minus that, you get 41.124 degrees. So again, with law of cosines, it's very particular about what angle you find first, given side, side, side. Find the biggest angle first. All right. So we've talked about law of sines and cosines. So there are certain cases where you want to use law of sines and where you want to use law of cosines. Like what we talked about on the front side, if you're given all three side lengths, you have to use law of cosines. If you're given side angle side, you have to use law of cosines. If you have that ambiguous case of angle side side, we have to use law of sines. Angle angle side, and angle side angle, you use law of sines. So what we're going to do is we're going to do a couple of examples where we're given information, we're not solving it, we just want to know what law we're going to use. So again, it's helpful to draw a picture each time. ABC, ABC. So we're given 29, we're given this is 18, and we're given that this is 13. Well, if you look at this, we have a side, an angle in between them, and a side. So that's just side angle side. So if you look at the table, we have to use law of cosines. So let's draw another triangle, A, B, C, A, B, C. So we're given 32. We're given that this is 8, and this is 6. Well, if you look at this, this is angle side, side. So that means we have to use law of sines. Again, a good way to tell is if you're given both parts of the information. Here we're not given both parts of C, both parts of B, or both parts of A. Here we have both parts of A in order to use law of sines. So A, B, C, A, B, C. So we have 3, 2, and this is 141. So this is side angle side. So it's law of cosines. Well, here you can already see that there's not even an angle. This is side, side, side. So it has to be law of cosines. You have to have at least one angle to have law of sines. Okay. So number 5, we have A, B, C, A, B, C. So this is 32.5, this is 69.3, and this is 10.2. So this is angle side angle, which means I have to use law of sines. Again, with this type of problem, you can find a third angle by subtracting those two from 180, and you'll have both parts of C. Given one angle, you have to be very careful which law you're actually going to use. So here we're given 51 degrees, this is 43, and this is 39. So another side angle side, which is going to be law of cosines.